In this video, we're going to talk about prime factorization. So we're essentially going to take a number and break it down into just its prime factors. We're going to do this by using a factor tree. So this first example, they're looking for the prime factorization of 4. This one's going to be really simple because 4 is such a small number. So with 4, we think about factors that multiply to 4. And the only one I can think of is 2 and 2. 2 times 2 is 4. As soon as you have a prime number at the end of your factor tree branch, I want you to circle it so you know you're done there. 2, we know from our little poster over here, is prime. So the prime factorization of 4 is simply, 2 times 2. That's it. This example, they're asking us to do the prime factorization of 50. So I'm thinking, okay, what multiplies to 50? Jumps into my head first is 5 times 10. Okay, I think 5 is already a prime number, so I'm actually done on this branch already here. But 10 is definitely composite, because I know 2 times 5 equals 10. Okay, so I've broken down and I have another one here. 2 is prime and 5 is prime. So I have my prime, I'm done all the branches, they're all prime numbers. So my prime factorization is 5 times 2 times 5. Miss Cooper, that's not one of the options up here. The order of, and this is one of those properties, the commutative property I believe it was. Doesn't matter the order, 2 times 5 is the same as 5 times 2. So as long as we have 2 5s and a 2, we're okay. And I see that here, 2 times 5 times 5. So that is the same as what we have here, just in a slightly different order. Okay, but another question, Miss Cooper. When I was looking at 50, the first thing that came to mind for me was 2 times 25. There is another way to do it. I'll tell you now, you're going to end up with the same prime factorization, so it doesn't matter. But let's prove it to you. So already 2 we know is prime, and now we have 25, which is composite, so we have to break that down into prime numbers. What's 25? I think of 5 times 5. Boom. Prime number, prime number. Again, we have 2 times 5 times 5. Both ways are correct. Both came to the same answer. Yes, they're in different order, but because of the commutative property, doesn't matter. And our last example, prime factorization of 45. When I look at 45, I immediately think 9 times 5. And 5 already, prime number, so we're done with that branch. But 9 can be broken down further. I think of 3 times 3. Boom. Prime number, we got it. 3 times 3 times 5. Which we can see is right there. That's it for prime factorization and factor trees. Good luck with this section.